I'll get started here. I think I have a scripture to read to start us here. This is John chapter 16, verse 33. It says the following: "These things I have spoken to you, so that in me you may have peace. In the world you have tribulation, but take courage. I have overcome the world." That's John 16, 33. I'll begin with a word of prayer. Dear Heavenly Father, we thank you for this day. I thank you again for this class and this opportunity we have just to meet and study calculus together. Just pray that you'd be glorified in what we do, and that students will be able to just ask any remaining questions they have about the homework this week, Lord. In your name I pray, Lord Jesus. Amen. All right, have at it. Ask away. As you guys know, Mission 5 is due tomorrow. Yes, yes, sir.
I guess I'm going to say 212.
212. So this is pretty much the example we worked in class, like Thursday, I think. So,
I did it right up until like plugging it in, and either or I feel like I saw dy over dt and dx over dt.
let's see here. Let me just say some words about it rather than writing anything down. So I would say, like, for this problem 212, I would let x be the distance from, the base of the ladder to the wall, and let y be the distance of the top of the ladder from the base of the wall. So x squared plus y squared equals to 100, right? And let's see here. You also know that dy dt is equal to what?
I got negative x dx dt over y.
Yeah, but dy dt should be what? I mean, you're given that it's...
Oh, dy dt is 2 feet.
But it should be... But y is y increasing or decreasing?
Decreasing.
Right, so you want to say minus 2.
Yeah.
So like dy dt would be minus 2 here. At the point what? At the point when x is equal to 4. Now if x is equal to 4, what's y equal to?
Oh, 9.165.
That sounds about right. I don't remember off the top of my head, but... So that's like... Okay, square root of 84? Yeah. So then you just differentiate the x squared plus y squared equals to 100. You have like 2x dx dt plus 2y dy dt equal to 0. And then you can solve that for the dx dt.
That's why I messed up. I solved it for dy dt.
Oh, no. You want dx dt. That's what you're looking for, because the question is how fast is the base of the ladder sliding horizontally away from the wall? So in our setup, that would be dx dt. But we did do this. This is like one of the examples I did, I think, Thursday.
That's the part where I got confused.
Ah,
I solved the wrong thing.
that's all good. Other questions? Yeah. 201E. I hope I can do it today. Oh, yowzers. Let's see here. I'm just joking. This one's easier. To me, all the related rates problems are harder than the differentiation problems, right? Anytime words come into this, anytime words enter the scene, it just makes it harder, doesn't it? Words should not be in math. That's why we put them in physics. Let's see here. So 201E. So you got yourself y cubed cosine of x squared plus y squared, all right, equals x to the 4th. And you're supposed to do what? Calculate dy dx, right? So you're just not quite sure where to start, or?
I just got lost for making the inside.
Okay, so let's see here. So what we're going to do, so our goal is to find dy dx, right? All right, so what we want to do is differentiate both sides with respect to x implicitly, right? So like d dx of y cubed cosine of x squared plus y squared is equal to d dx of x to the 4th. Now the right-hand side, I'm sure you're fine with, right? 4x cubed, we got that, right? The left-hand side, we need to look at it as a product of functions. So what we're going to have here is 3y squared dy dx. That's the derivative of y cubed, right? Times the cosine of x squared plus y squared. Plus y cubed times minus the sine of x squared plus y squared. And I'm going to write out a step here, d dx of the inside function, which is x squared plus y squared. Now, some of you might be able to do that without breaking up into steps. Maybe some of you have already lost me because I didn't put another step down. I don't know. I'm trying to make everybody unhappy. I hope I've achieved my goal. But this is the product rule, right? Do you guys understand the pattern here? Let me just write it down again. So I'm thinking of this as like f. I'm thinking of all of this as g. So what you're looking at is f prime g plus f g prime, right? Product rule. Yes, no?
Yeah, I got it.
You got that far, okay. And then what we get is 3y squared cosine of x squared plus y squared. I'm just bringing the dy dx out here. And then I've got minus y cubed sine of the sum of x squared and y squared times, I'll put some square parentheses here, 2x plus 2y dy dx. All right. So do not despair. Like every one of these problems will fall down to the same algebra technique. All right? Like this is what you have to do. Differentiate it using the chain rule like we just did. After that's all done, put all of the terms with dy dx on one side, put all of the terms without dy dx on the other side. You will be able to factor out dy dx. I repeat, you will be able to factor out dy dx. So like here, I get 3y squared, the cosine of x squared plus y squared, minus 2y to the fourth power, sine of x squared plus y squared, all of that times dy dx is equal to, you got yourself a 4x cubed over there, but let's add a plus 2x y cubed sine of the sum of x squared and y squared. Let me do some color coding to explain to you the method I just used. So I took this term, I put it here. I factored out the dy dx. Okay? Then, again, my goal is to solve for dy dx, so I want to isolate it. Multiplying this out gives me this times that, which gave me this term here. And again, I factor that out. Does that make sense? So you're just like stuck on the this algebra step was where you got hung up?
Yeah, I couldn't get dy dx.
Ah, yes, yes. And then of course I just moved the this guy. I multiplied it by all this, and that became this term over here, right? Minus became plus because I put it on the other side. And now finishing blow, we just solve for dy dx, right? Which at this point you can see how to do, right? So after you do all that, it's kind of obvious how to solve for dy dx. You just do 4x cubed plus 2xy cubed sine of x squared plus y squared divided by 3y squared cosine of the sum of x squared and y squared minus 2y to the fourth sine of x squared plus y squared. And I'm sure there's a way of simplifying and or rewriting that, but I will not do that. So I'm just going to leave it just like that. That's fine. So you guys ready for the math battle tomorrow? Yes, no? Also known as pretest, right? It's a pretest, a group pretest, trying to give you guys a leg up on the test Thursday, right? So if you don't know how to do something tomorrow or today on the quiz, right, you need to try to remedy that before Thursday comes around, right? So 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 test 2 is what's it on? It's on the material that we've covered after test 1, right? So it's going to be mostly on differentiation, right? There might be, like, where would limits appear on this test? The only place it might appear is I might ask you to, like, prove one of the differentiation laws. If I was to ask you to prove a differentiation law, it would either be to prove that the sum of the derivatives is the derivative of the sum, or to prove the product rule. It would be one of those. I will not ask you the proof of the chain rule on the test, and yeah. Now I might have a problem for you guys to derive the like the product rule for third derivatives or something, because you had a homework on that. So that's possible, I suppose. But that's less of a proof. It's more of a kind of just a calculation. The proofs are the ones that you need to know the definition of the derivative. You do need to know the definition of the derivative in terms of a limiting process, like going forward. Once we've covered that, it's something you're expected to know. But of course, the lion's share of the focus on test 2 is not going to be on limits and difference quotients, right? It's going to be on applying linearity, the product rule, the quotient rule, the chain rule, lots and lots and lots of chain rule. And then the more recent things that we just did, like related rates, linearization, the implicit differentiation stuff that we're talking about, and of course log differentiation. So, other questions? Yeah. 229. Can I go over what I mean by what? Oh, okay. So I think what I'm really just looking for there is for you to make a graph of the cube root of x plus 1. So if you can see the graph of the cube root of x plus 1, and then you can picture the tangent line, right, based at 0. So, whoa. So the tangent line's at 1, 1. The point of tangency is 0, 1. I think. Yeah. It's that's the cube root graph shifted 1 to the left, right? I mean, correct. So if you graph the actual cube root function there and the tangent line, which, the tangent line so the graph of the linearization is exactly that tangent line, right? That's what the linearization is. It's the function whose graph is the tangent line. And if you look at the graph of the cube root of x plus 1, you can compare that, say, to the graph of the tangent line, and it should suggest something about the error in the approximations that you've calculated as being, well, first of all, whether it should be an overestimate or an underestimate, right? And second of all, like the size of it. Both of those should kind of be evident from the graph. You remember we did this in class for the square root? It's the same idea, but for your problem. Yeah. If you if you have had a more systematic discussion of error in like a chemistry class or something, you could do that if you wanted. Like, you could calculate absolute error versus percentage error. I mean, I don't know. Like, I'm open to other, if something else is more natural to you in terms of discussing error, you're welcome to do that too. But like, I'm just really looking for a graph and like a comment or two, not much. Yeah. 202. Let's see here. I can talk about it, perhaps. Oh, yeah, sure. We can do that. So 202, we have y squared. Yeah, because we have not run up against any example quite like that in class. So I'm happy to do it with you. So here we've got y squared equals to x cubed plus 1. We're supposed to calculate y prime prime and express answer in x and y. All right. So I'm going to use the prime notation for a change here, right? So if we differentiate this with respect to x, what's it give us? It gives us 2y, y prime, equals to 3x squared. Does that make sense? I'm using I've been writing dy dx predominantly, but we could also express it with the prime notation. And you guys are allowed to use the prime notation like on the test and such, but if you do, please make it so that I can see it. Some people have more ghostly writing, so I lose track of it. It's hard to miss a ddx. You know, it's easy enough to miss a prime. So, all right, well, great. If we wanted to find dy dx, we could do it here, right? So, or y prime. Y prime is equal to what? It's equal to 3x squared divided by 2y. So, right? Or you could write dy dx if that makes you feel better about it. Now, that is not the answer to the problem, but it's notable, right? So then how do you find y prime prime? Yeah, now we could either take the derivative of this, or we could take the derivative of that. I'm inclined to take the derivative of the original equation because it's easier. There's no, I don't have to do the quotient rule or anything, you know? So I might as well just take ddx of this, and we'll get 2 y prime plus 2y y prime prime equal to 6x. You know what, I'm going to write down some steps because I think that's probably going to lose you guys. Let me drop back to the ddx notation. Make sure we're all on the same boat. Let's see here. So we've got 2 times ddx of y times y prime plus 2y ddx of y prime is equal to ddx of 3x squared. What did I do? I did the product rule because y and y prime are both functions of x, right? So I have to do the product rule. And what I have then is 2y prime plus 2y double prime is equal to 6x. And so I can solve this all for y prime prime. I get y prime prime is equal to 6x minus 2y prime squared divided by 2y. And so let's clean this up a little bit. We've got a 2 we can cancel out, right? So we've got ourselves a 3x minus y prime squared divided by y. I'm asked to leave my answer in terms of x and y, right? So what do I need to do? I can't leave my answer like this, can I? Because I've got a y prime in the answer at the moment. How do I fix that? So I got this right here, right? So I just take that, plug it down in there, and now I've got an answer just with x and y, right? So I've got 3x minus 3x squared divided by 2y, quantity squared, divided by y. I don't think I asked you to simplify the answer, but if I had, I think the next thing I would do would be like, okay, so that's 3x minus 9x to the 4th divided by 4y squared over y. So that would be like 3x y squared minus 9/4 x to the 4th divided by like y cubed. So you could write the answer like that. You could anyway, we could simplify the answer, but we don't have to. Yeah.
I probably just did a maximum, but I took the square root of y and the square root of x.
Oh, okay. Sure. Yeah, you could do that. That's a possible.
Or in terms of all X's?
Yeah, that would be fine. But your answer is going to look totally different than ours, right? But they will be equal if we sort through the connections between x and y and compare answers, assuming you differentiated correctly, which I think is a fair assumption. So, yeah. Don't worry, if I ask this kind of question on a test, I'll make sure it's not possible to solve for y. See, what I should have done is something like this. I should have been like y squared plus y to the fifth, aha, equals to x cubed plus 1. If I'd done that, and then I said find y prime prime, then that route of calculation would have been inaccessible. Yeah, but you're not wrong. That's a perfectly good way to do it, yeah. The point of this example was to make you guys aware of these kind of calculations. The fact that, we can differentiate something like this again, but we should, we'll face things like y prime squared, and what you do with that. That's like, this discussion is why I have this homework problem. But you found a way around the discussion, so that's good. Not a bad thing. Other questions? Yep. 219. All right, let me see if I can. So you've got a path. You've got, I'm not going to try to draw perspective. I'm going to draw it. This is a right angle, right? The dude's walking over here. Mr. Top Hat, let's say. And I'll make this angle theta because they also make the angle theta. We're told that this length here is 20. A man walks a straight path 4 feet, so he's going 4 feet per second. This distance here is called x. The searchlight is 20 feet from the path, and its beam is kept focused on the man. At what rate is the searchlight rotating if the man is 15 feet from the point? So the question is basically this: what's d theta dt when x equals 15 feet? That's problem 219. So what do you guys think you should do? So every related rates problem, there has to be some kind of fundamental algebraic relation between the variables, right? You figure out what that is, and then you differentiate it to relate the rates. So what's the relation between x and theta and the 20? What should we use? Tangent? Yeah, I think that's right. Tangent's opposite over adjacent, right? So we'd have what? Tangent of theta equals to what? X over 20. Excellent. So if you know that, right, you can so both theta and x are functions of time. So if we differentiate this with respect to time, what does it tell us? We get like secant squared theta d theta dt, right, is equal to 1 over 20 dx dt. And basically, we want to solve for d theta dt and try to figure out, what would secant theta be when x is equal to 15? You got what triangle? At the moment you're interested in, you got this triangle, right? 20, 15, theta. So there's various ways to go here. One way would be to find a good approximation to the angle using the trig functions on your calculator. Then you could put that into the secant squared and figure out what d theta dt is, right? The other way would just be to use right triangle trigonometry. So this would be what? The square root of what? 400 plus 225. So the square root of 625, whatever that is. Oh, it's 25. Huh, cool, well, And so that tells me that cosine of theta is actually what? Cosine theta is adjacent over hypotenuse, right? So like 20 over 25, which means that secant theta, which is 1 over, cosine theta, is actually like, 25 over 20. So you could actually use that at the specific time you're interested in to figure out what d theta dt is. I can't write down much more, otherwise I'll have solved your homework problem. And I don't want to solve all your homework problems, so I'll leave you something. Does that help?
Yes, sir. Thank you.
Cool. Uh-oh. You guys are all free of that bug, right? We're past that now, right? No one's got the whatever that was. Not the rot, to be clear, not the rot. It's been scientifically proved, right? Yeah. It is kind of funny. Like, it doesn't matter what happens of that nature. It's going to get blamed on the rot, right? Like, that's just a fact. People could, like non-Liberty students could get sick in like Madison Heights or something, and it would still be blamed on the rot. Just because, Anyway. Other questions?
Problem 226, I want to say.
226. Well, I think I did that one in class, more or less. That's the square root based at 4. So, I could start problem 230 for you guys if you're interested in that. So problem 230. Problem 230, you're supposed to find the linearization of f based at 0 for f of x equal to e to the x, right? So remember, LF of x based at a is by definition f of a plus f prime of a times x minus a, right? So if we put 0 in, what's the linearization at 0? By the way, what's f prime of x here? F prime of x is e to the x again, right? So both f of 0 and f prime of 0, they're both equal to what? Well, they're both equal to e to the 0. What is e to the 0 equal to? It's equal to 1. Very good. So this is literally just like 1 plus 1 times x minus 0. In other words, the linearization you're looking at here, you could either write as 1 plus x or x plus 1, whatever floats your boat. But there you go. That's the start of problem 230. That's the formula for the linearization. Now you can try plugging it in and seeing what happens. And then, similar to my answer to Caleb's questions earlier, you want to graph e to the x, you want to graph the tangent line, and that should help you explain why one of the approximations is an overestimate and one's an underestimate, if I remember right. I think. They might both be underestimates. I can't remember. Well, anyway. Other questions? All right, I think we probably should get started on the quiz because you guys still need time to do that. So let us begin. If you were sick or something last week and for some reason have not turned in your homework, now would be the time.